So we're going to take a little bit of a break from matrices in this chapter, but they're coming back in a big way in chapter 8. So don't forget, you can't forget everything that we learned about matrices, but we're going to do a little something different here in chapter 7. So chapter 7 is all about what's called linear programming. Linear programming. And so what's the idea here? Here's the kind of question that we want to be able to answer in this section. I'd like to be able to answer this question, which is, how can I either find a maximum or a minimum of a given function? So our big goal in this chapter is to find maximums or minimums. So maybe it should be minimized. My grammar is off. Minimize. How can I maximize or minimize a given function? What's a function? Well, I'm not going to go into hardcore what a function is. I'm sure you guys have heard of them before in like an algebra class or something before, or J111 or something like that. We're not going to harp on what this word really means in this class. For us, it's just going to amount to like a formula or something that we're going to plug numbers into. But the idea is I want to maximize or minimize. So, here's like a typical example. You run some business and you sell some product. I don't know, you manufacture cars or something. And you know that you have some amount of materials available to produce cars, and it costs you so much money to produce a car. The question that you might ask is, how could I maximize, say, profits for selling cars? How many cars should I make and sell to hopefully maximize profit? Okay, that's a very typical problem. Or something that you might want to minimize might be cost. How could I minimize the cost of producing something? Yeah. So these are the kinds of questions we want to be able to answer in this chapter. And so we're going to have a lot of word problems like this, where you're the owner of some business or something and you have to maximize profits or whatever. Yeah. And these are kinds of problems that we want to be able to answer in life. I don't know. If you run a business, these are kinds of problems you need to be able to answer. And so our tool for answering these problems will be what we call linear programming. And we'll see exactly what that means maybe later, not necessarily in this section. In 7.1, here's what we're going to do. We're just going to learn how to set up problems. We're going to learn how to set up linear programming problems. It turns out these problems are kind of complicated. There's just a lot of parts that we have to describe. So we're just going to spend this section just seeing what the problems look like and how to set them up. That's all we're going to do here. And so your first activity, that 7.1, is really just setting up a bunch of problems, and you won't actually solve anything yet. So there's really no math in this section at all. It's all just setting things up. So let me introduce to you some vocabulary, and then we're going to see a bunch of examples. Well, maybe not a bunch, but we're going to see some examples to set these up. So here's our goal in this section. We are given what's going to be called an objective function. We're given an objective function, and I'm not really going to define it, but I'll point it out once we do some examples exactly what this is, but it's just going to be some formula that we're going to plug numbers into. And this is the thing that we're going to maximize or minimize. So we need to maximize or minimize the objective function. And when I say maximize or minimize, I'm going to look for either the biggest or the smallest value that the objective function can take. But we're going to be a little careful. We're going to subject it to some constraints. So this is our other key word here, is constraints. Constraints, I can tell you what these are. The constraints are going to be inequalities. And there'll be linear inequalities, hence why we call this linear programming. We have linear inequalities. So certainly you guys have seen inequalities before, but just to remind you what that really means. I'm talking about things like this, like x plus y less than or equal to -2 or something, or 2x less than or equal to 3y, maybe greater than, to get some variety here. The idea is we're going to have these, instead of equal signs, we're going to have less than or equal or greater than or equal signs. And I'm going to trust that you guys remember what these symbols mean. I mean, they kind of define themselves. Less than or equal to means that the left side is less than or equal to the right side, and so forth. These will be our main players here. So instead of having equations, we're going to have a lot of inequations, right? Inequalities are going to be a big thing for us. And those, in this fancy language, we're going to call constraints. So these are our constraints. Okay. Cool. So this is basically our goal here. I'm going to give you some objective function. I'm going to ask for either the maximum or the minimum, and it's going to be subject to some constraints. The constraints come into the real world example, like, if we go back to this idea of selling cars or something, you can't just produce infinite cars, right? You have a limited amount of resources if you are a car manufacturer. You have a certain amount of steel or oil and parts and whatever, and you have a limited number of workers and labor time and all that, right? You are limited by the amount of materials at your disposal, and so that's where constraints are going to come in for us. They're going to be limits on like the amount of materials for producing an object, or the amount of time that you have to produce something, or the cost, how much money you have to spend on something. So the constraints are sort of what make these like real world problems. They keep us grounded in reality. Okay. So this is our very vague at the moment setup. I haven't really told you guys anything yet, but this is where we're going to go. And so to really illustrate what I'm talking about and how these work, I am basically now just going to jump into an example and sort of explain piece, step by step as I go, what each piece is and what we're going to do to set this up. So that's what I'm going to do now. Let's see our first example. Again, we're just going to set up the problem. So just to be clear about what that means, to set up, here's what we're going to do. We're going to find our objective function. In some problems, this might just be given to you explicitly, but maybe we have to read the word problem to figure out what this should be. So we're going to find our objective function, and then we're going to find our constraints. And I'll note that there are two types of constraints. There are the explicit, and these means, oh my goodness. Explicit constraints are given in the problem. So these I'll be able to read from the problem based on the information given. And there's also implicit constraints, which are not given explicitly. So they're just the opposite of explicit ones. But they're some inequalities that we have to include so that the problem makes sense. And again, I'm being vague at the moment. I'll do some examples and make everything clear, exactly the difference between these, and I'll point out what I'm doing. So this is pretty much all we need to do. Find our objective function, find our constraints. Okay. So let's go ahead and do that for an example now for real. Okay, and I had one here that I wanted to take. So here's our example that we're going to work on. So let's say we have a manufacturer of roller skates, a manufacturer of roller skates, inline roller skates. I think this is an old book. Inline rollerblading was like super popular in the 90s. I don't think it is so much these days. I think this book is from like the 90s that I'm stealing this from. Anyway, we have a manufacturer that makes two models of inline rollerblades. So there are two models of rollerblades. Maybe these models are called California model, and the other one is Florida. So these are just two different styles of rollerblades that they make. Okay. And there are two operations involved in producing these rollerblades. So we're some rollerblade manufacturer. We manufacture these two models. There are two operations involved in the production. So there are two operations. There are finishing. So there's frame finishing. You're not privy to the manufacture of rollerblades. It doesn't really matter what this actually means. We'll just, this is something we have to do to make rollerblades. So there's frame finishing and installing wheels. Let's say. These will be the two things that we care about. And so what do I know about these two things? I know the following. I know that these two operations take the following amounts of time. So you are a manufacturer of rollerblades. You have a certain number of employees. You only have a certain amount of man hours to allocate to these two operations. And each one of them takes this amount of time. So for the California, make a little table here. For the California, to finish the frame takes 15 minutes. So these numbers are going to be in minutes. And to install the wheels takes 5 minutes. So for every pair of California roller skates that I'm going to make, it takes 15 minutes to do the frame. It takes 5 minutes to do the wheels. And for the Florida model, maybe it takes 10 minutes for the frame and it takes 20 minutes for the wheels. Okay. So I now know how much time it takes to produce one of each model for each of these operations. Okay. So I'm going to tell you a little bit more information now. So one thing you'll notice about these types of problems is there's sort of a lot of information to get out in writing. I have 120 hours of labor available. So that's how much time I have available to produce skates in a day. Maybe we'll say in a day. Every day I have 120 man hours available to produce skates. And the profits, the profit per California model is $15. And the profit for the Florida model, per Florida model, is $18. Okay, $18. So $15 per California model and $18 per Florida model. Those are my profits. So here's the question. How can we maximize profit? So we want to maximize profit. That's our question, of course. We're in the rollerblade business. In business, we want to make as much money as possible, right? So how do we maximize profit? That's the question. All of this information that I've given you will be relevant. We need every last detail that I gave you. And so I'm going to show you how to set up the problem. Again, we won't solve this today. I just want to show how to set it up. So what did we need to find? We're going to have to find our objective function, and we're going to have to find our constraints. Yeah, we have to find our constraints. And so we'll just need to remember all this information that I've written down. So hopefully, if you guys are following along, you've written this down as well, all this information. So I am limited by board space, so I may be erasing as we go. Maybe I'll try to leave this table down here for now. Okay, so let's begin trying to set this up. We want to maximize profits.